is there a composition of transformation that maps triangle XYZ to triangle JKL? Explain. Oh my. Now, story, okay? When you're asked to explain, you tell a story. All right, so that's what we do. So now, let's help ourselves with identifying our correspondence. It's going to be X, Y, Z right here, and we want it to map onto J, K, L. Our goal is to hit it with one rigid motion followed by a dilation. All right. So although there are several ways we can map triangle XYZ to triangle JKL, we'll shoot for just two steps: a rigid motion and then a dilation. Now, if you look at this one here, we can try rotation. If you rotated triangle XYZ, okay, you know, rotation, also by way of review, a rotation by 180 degrees centered at the origin actually will give you X comma Y will just give you negative X comma negative Y. All right, so this is going to happen. So meaning X with coordinates 2 comma 1, after the rotation will have coordinates -2, -1. So X will go right there. That's our X prime. This is going to be, and also, okay, this is our X prime right here. So X prime, and then our double prime will be J. So, and then Y with coordinates 1 comma 4 will have the coordinates -1 comma -4. This is our Y prime. Y prime. All right. And then Z with coordinates 4 comma 1 will have coordinates of -4 comma -1 right there. So you can see that, okay, let me just show you one pair. Okay, this one is rotated 180 degrees. Boop, boop. Okay, that's 180 degrees. Same thing with this one here, 180 degrees. So everything is rotated 180 degrees. This is going to be Y prime, and then this is Z prime. Now it's going to beep, 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 beep. All right, so after the rotation, so you see how everything else is rotated. Now that's rotated also 180 degrees. Z, ooh, I don't want to mess our figure, so let me remove that. Chit, chit, chit. All right. Now the next step will be dilation. So because we have the matching already, Z matches with L, Y matches with K, and X matches with J. All right, so now let's do our dilation. Main problem here is that what will be our scale factor? Okay, the scale factor would be, okay, if we dilate from 0, would be what? Okay, well, let's compare. Okay, I'm picking this side and this side because they're easy to count. Don't make it hard on yourself. It's gonna be, let's see, X prime Z prime, or Z prime X prime. It's gonna be X prime, scale factor right here. The scale factor is equal to, okay, since we want LJ to be our image, okay, let's see first. Okay, let's list down what we have first. It's gonna be X prime Z prime is equal to what? 1, 2, 2. Okay, that's 2 steps. 1. It's gonna be 1, 2. That's 2 units. Now LJ, which is what we want to end up on, is to say 1, 2, 3, 4. It's gonna be 4. So what is our scale factor? We know that in a dilation, okay, the length gets longer or shorter by the scale factor. In this case, we want X prime Z prime to get longer, to be equal to 4. Now what do we multiply x prime z prime to get 4. It's going to be, our scale factor is what? Times 2. Our scale factor is 2. So 2 times 2 is equal to 4. So you see here 2 times the scale factor of 2 is equal to 4, which is that. Okay, our steps is, okay, it's going to be rotation 180 degrees, centered at the origin. And then number 2 is dilation. Okay, scale factor is equal to 2. Okay, scale factor is equal to 2. So our composed transformation, okay, since dilation is done last, it's going to be dilation, scale factor of 4, composed with rotation of 180 degrees around the origin, so we don't have to indicate it. Okay, every time the center is the origin, you don't have to indicate it. It's going to be triangle x, y, z. All right, so that's our composed transformation. So now, what do we conclude? Since we were able to come up with a composition of transformations involving rigid motion and a dilation, a non-rigid motion, okay, to map a triangle XYZ onto triangle JKL, okay, our conclusion here is that triangle XYZ, therefore triangle XYZ is similar to triangle JKL. Okay, so the implication of this composed transformation that involved the dilation is that the two figures are similar. If you have to write your story, okay, make it, just put in some details and then put them in words. Okay, of course we're doing maths, so it's going to be most of the information are symbolic in nature. Well, see you next example.